Peter Bartlett. We're a collaborative research institute in theoretical computer science, but with a outward-facing view. It's computer science and other areas of science and technology and society, particularly, where a computational perspective is important. We run 2 main programs each semester that bring long-term visitors here, and also these shorter, smaller, often more speculative summer clusters, aimed at I guess, perhaps less established topics that we can organize more quickly. We're very happy to be hosting this cluster on AI and humanity over this summer, and welcome to the workshop for this cluster. First of all, a big thank you to the organizers, Helen Nissenbaum, Thomas Crendell Gilbert, Jake Goldenfein, Connell Parsley, and Jian Yang. Thanks to those folks. Got a great schedule for this week. I'll hand over to Helen to introduce the workshop in a moment. Just a few words on logistics. So you should have discovered the food and coffee. That's there for breaks. For lunches, you're on your own through the 3 days this week. Masks indoors are strongly recommended. Outdoors, of course, you're welcome to wear a mask. We ask you not to bring food and drinks inside into the auditorium. Please enjoy those outside. Water is fine. At lunchtime, if you need to leave some belongings here in the building, there are lockers on the far side that work with a PIN code, so you're welcome to make use of those. You should have all discovered Wi-Fi. Our videographer is Omid Farr in the booth here. He's going to help speakers hook up computers and microphones, because of course everything is streamed, and we've got video available on YouTube and the website. And also a big thank you to Elizabeth Yuen, our events coordinator at the back here, for all the local arrangements. All right, so enjoy the 3 days of the workshop. Looking forward to it.
I'm Helen Nissenbaum, and let me take the opportunity to thank Peter for somehow within the definition of the Simons Institute, managing to squeeze us in, because this has been very generative so far. So thanks, Peter. Thank you so much, Elizabeth, and just generally to the Simons staff, who are fantastic and have been incredibly helpful. So a few other thanks. You heard who the co-organizers are. We've been meeting over the course of, how long? Since January, across crazy time zones, and just trying to formulate the conception behind both the cluster and also the workshop. If you've gone to the website, you've seen this notion of AI and humanity entering through this issue of human-centered AI, which is, I think, one of the latest "don't worry, AI is great" phrases. And our thought is, what is the human part of this dyad? Because a lot of attention has been grabbed by the AI part of this dyad, but what assumptions are built into AI about the humans, and is that good for humanity? And is it good for societal institutions? Is it good for our values and so forth? So that's the perspective we wanted to take just for this cluster. And even with well-meant technologies like assistive robots, smart devices, decision assistants, we keep pushing at this question: what are the humans that are modeled or represented or embodied in those systems? And are they beneficial for humanity, again, for society, for values, for institutions, and so forth? So I should mention that using this as the theme, people were identified as doing work relevant, and particularly for this workshop, we wanted to include participant speakers who could bring insight to these kinds of questions. And so the next thank you is for everyone who's sitting in this room, everyone who's agreed to give a talk, because this isn't your standard disciplinary workshop. And we have at least 9 or 10 disciplines represented in the group, depending on how you count. And it's not always easy to know, because many of us are cross-disciplinary. I am officially a philosopher, but I've absorbed all sorts of other disciplines, because this problem, this question, isn't, in my view, something that can be solved by drawing on the intellectual resources of only one discipline. All right, so I'm not going to steal too much more time away from the panel. And just to let you know, we've built in a very nice long lunch so that if we do need to push a little bit, and we're not going to let people go much over time. I have this bell. Thank you, Peter. But no, I mean, I'll just be a little bit bossy in making sure that we stay on time. Each speaker will have approximately or no more than 15 minutes. And then we will clump together the discussion, which I'll moderate. Just one more house. Did I forget anything? Partners, Jake. Okay. About the masking, I think I'm going to go around. Peter, can we open the exterior door?
Yeah.
Just to, maybe get a bit of airflow into the room. I think often the rule can be that the speaker can take his or her mask off, but we request that others use masks, but we will try and get some airflow into the room. All right. So our 3 speakers are Tom Gilbert, who I'm thrilled to have as a postdoc at Cornell Tech at the Digital Life Initiative, Jian Yang, who will be second, and Bernard Keenan, who joins us from Birkbeck. Thank you. I'm pleased to see you from Birkbeck College. So let me welcome you in hand.
Thanks, Helen. I think I've mic'd. Okay. Yeah. So greetings, everyone. It's an honor to be here. I should say technically back here since I was affiliated with the Simons Institute in fall 2020 on a program for the semester called Theory of Reinforcement Learning. And actually many of the ideas in this talk were born in that convening originally. So that's also to say, again, like thanks to Peter for helping with that previous program and for providing me the space to develop a lot of the perspective I'll briefly kind of outline in this talk. So this is based on one of the chapters of my PhD thesis. It's now been subsequently published. And it's really a kind of window into what I was doing for a lot of my PhD, which was here at Berkeley. And I was based primarily at a lab called the Center for Human Compatible AI, or CHAI for short, as we affectionately called it. And it was a lab that was concentrating on what is known as a problem called AI safety, a research field called AI safety. And the goal of AI safety is basically to solve the problem of making AI beneficial by building what they call, and you can check the website for the language on this, but what they call provably beneficial systems. Where provably beneficial was a term that was often used in talks and on the website and in various documents, but was never, in my view, was never actually interrogated or explored. And I joined CHAI self-consciously as a humanist because I was interested in this problem of defining what beneficial AI might mean, or just what beneficial might mean itself, especially in relationship with Another emerging research field, which I think many here are familiar with, which often goes by this kind of fairness, accountability, transparency lens on AI systems. I'll just sort of more broadly refer to it here as the politics of refusal, where the question of how you might build beneficial AI is rooted not in terms of some abstract formal model that is accurate with respect to what it's trying to model about people or institutions or choices people make, but rather in the endorsement or the affirmation of affected communities. But basically, unless you have some kind of positive signal, so to speak, from the people most affected by what you're building, endorsing what you're doing as a designer, unless you have that, then what you're doing is problematic, regardless of bias, regardless of the data on which it was trained, anything like that. And I came into CHAI because I was interested in the tension between these two perspectives on this problem. And I got really interested in not so much sort of speaking up as a humanistic critique, which I was doing externally, but rather to try a version of what I came to really own as a form of immanent critique, which those of you who are familiar with critical theory or the Marxist tradition, you know that immanent critique is basically a way of trying to bore into a paradigm from within to uncover within it contradictions that are not resolvable within that paradigm as a basis for moving forward. And for me, that was sort of a very interesting question of what is an immanent critique of AI? What would that mean today to become a computer scientist and to have a profound skepticism in this paradigm, even as I became very intricately involved in it. And that was really the root of this work for me. So I started learning, which I was trying to do, and that a lot of the technical agenda that they were pursuing, that AI safety was pursuing, that they're still pursuing, I should say, is conceptually rooted in a paradigm that I think was well expressed by William MacAskill. He's a philosopher. He's more often known as one of the founders of effective altruism. It's a very prominent kind of ethics movement on the global scale, which I'm happy to speak a little bit more about during the Q&A or the panel if we want. But MacAskill's view is that basically the way we should go about solving trolley problems, which is to say the kinds of moral dilemmas that you can formally model and conceivably resolve through some kind of like revealed or expressed preference from whoever you're asking about this moral dilemma, the dilemma of who you should kill in the case of a trolley problem, is what he calls metanormativism, which is basically a recourse to more data. In other words, well, if we knew more about what is at stake in that dilemma, if we knew more about the 5 people that the trolley might hit, or if the one person I might save is my mother or my aunt or my best friend or has terminal cancer or something like that, if we dissolve that abstraction by collecting more information from the world, we can basically use Bayesian inference to solve moral dilemmas. That's basically the idea here, that there's some kind of uncertainty over our assumptions that we can minimize, reduce the bias, and in so doing, solve a lot of the ethical and moral quandaries that AI is encumbered with when we think about the bias or the inaccuracy of these systems being built. So the resulting problem stops being a moral dilemma and turns more into a kind of practical dilemma of how do we leverage enough data? How do we get enough information from the world, from people, from institutions, so that the assumptions by which our systems are built are more robustly, more accurately modeled and incorporated. You basically reduce any kind of like fundamental tension between moral priorities into a question of epistemic inference. And this is a very influential position. I was kind of interested by how influential it was and how uninterrogated this was by many of the people I was actively collaborating with and working with. And, I don't want to dwell on this because I think I'm speaking to an audience that is maybe not so sympathetic to this way of thinking. So I'll just sort of briefly say that I was interested in this puzzle of like, well, where is the designer? Where is the AI designer putting themselves in the kind of epistemic hierarchy that defines whatever the system is that they're building? If you deploy a classifier for computer vision, for medical imaging, let's say in a hospital, there's a vast, largely informal, institutionally backed up division of labor comprised of just, some forms of expertise I put on the slide of whose judgment, whose discretion goes into its use, its application, what cases it's appropriate or inappropriate for, what ratio of false positives or false negatives are acceptable. It's a vast normative landscape that you just can't resolve by just getting more data, because that implies some vantage point, some perspective on the domain that is not neutral, because you're situated in that domain when you're looking at it, when you're building a system like this. And so I sat with this tension for years, because I knew and still believe that these assumptions and these ideas are going to inform what for the next several decades will define public policy for AI and economic policy for AI. That I think in 20, 30 years, a lot of the ideas behind AI safety are going to inform how the Federal Reserve works in 30 or 40 years, how we define economic policy for the remainder of the 21st century. That basically, if you think for the historical parallel here, is like the Chicago School of Economics in the 50s or 60s, right? Not really taken seriously by many other people, seen actually as quite outlandish. Milton Friedman was not taken seriously in his early career, right up until he was. And I was interested to be on the ground floor of a place like that. I wanted to ask myself, what can I say to these people about what they're doing? How can I help them and help myself even make sense of these problems in a way that actually could be conducive to the AI paradigm, whatever that means? How do we move maybe past or problematize the politics of refusal? How do we enrich it? How do we make it something that can be grokked by mainstream computer scientists and AI theorists? And so for me, I became much more comfortable with this language of what me and some of my collaborators came to call normative indeterminacy, rather than just uncertainty, which I'll just say for the purpose of this talk had two precepts, basically that social norms are not simply kind of discoverable through data or encodable in terms of your Python script or your API or whatever it is, but they're also like you're enacting them by the conditions under which you are developing these tools. This is an insight that, of course, goes back to like second order cybernetics, the idea that the designer of the system is also somehow implicated in the feedback that the system is taking in or generating. And I basically just refurbished those arguments, but tried to make it copacetic to the style of thinking, the patterns, and the dispositions of work that were now being pursued, in the lab I was a member of. And then secondly, the second kind of point here is that developing whatever safe AI means is really going to amount, among other things, to developing practices that affirm distinct value commitments, that how you comport yourself as a designer, how you professionally determine your relationship with the system you're building and the people affected by the system you're building, and how you justify that relationship is really at the core of what safety means. That safety is not just something you can put in a model or the system you're building. It's something you have to inhabit as a designer. And so analytically, what that then led me to was thinking about going back thousands of years, how have philosophers tried to make sense of this problem of indeterminacy? So in the paper that this talk is based on, we go into this in more detail. I can say a bit more during the panel. But basically, there's this problem of vagueness that is really central to the Western philosophical tradition. Hobbes basically took vagueness as the jumping off point for the relations of sovereignty. And vagueness broadly refers to this problem of the fundamental lack of clarity in the concepts that we use to describe ourselves, our relationship with the world, how we make sense of what we perceive. And there were basically three schools of thought that we in this paper argued were relevant for AI systems. Basically, that there is vagueness with respect to perception. There is vagueness with respect to the language we use to talk about the systems that we are building and the features that they observe. And there's also possibly a vagueness in our awareness or lack thereof of the reality that these systems are meant to refer to. The institutional apparatus, the social domains, the applications that they are meant to work on. And the payoff here was we basically said all of these positions, these references to indeterminacy actually manifest materially at distinct stages of AI development. So basically, when you hear AI developers talk about the need to specify a model, the need to define the features over which you are optimizing, the concern over who should or should not have access to the API, what you're actually hearing is in a practical sense, a kind of skidding up against the boundaries of these different kinds of vagueness. Because at different stages of AI development, we often talk about design, training, deployment. In the paper, we sort of basically elevate those kind of banal terms into the kind of philosophical correlates of what we mean by AI systems that interface with the world. What we call in this paper featurization, optimization, and then integration, all of which feed into this term we introduced, what we called sociotechnical specification, the problem of defining the relationship between the system and social reality. And so I'll just briefly, for the remainder of this talk, go into a bit more detail on each of these dimensions, how this indeterminacy can manifest. This is a very, I know Smith knows this very well. It's a very famous video that AI safety researchers love of a game, computer game, in which, if it plays here, I think it's called Wave Runner. You basically have a boat that they've trained. This is reinforcement learning that they used here. They trained an agent to try to win this race to compete with the other boats, and they used a proxy for what it's trying to do, because it's really hard to just sort of train it on win the race. So what they trained it on was get the most points. They assumed get the most points meant you're going to win the race. As you can see from the video, that's not true. What the agent has learned is that there's actually this weird little loop-de-loop that it can do because there's like turbo boosters or whatever like that. So you can basically get infinite points if it learns to not win the race, to just sort of like play its own game, so to speak. What's interesting about this is that the agent is doing exactly what it was told. The agent is not confused. The agent is not stupid. The agent is actually smarter, as specified, than any human who would play this game, because what it was told to do, it's found the perfect way to do, which is get the most points. And so this problem of featurization became kind of my way of referencing this problem of exactly what are the features of the domain, of the environment, that should matter most to what is being learned. And if you misspecify that, it's going to learn something that's not so much wrong as reinterpreting the world in which it's operating. And so when you hear people talk about existential risk due to AI, when you hear them talk about the paperclip problem, the problem of defining rewards, this is basically what you're referring to, is that the system is going to end up in a recourse where it perverts or contorts the world for the sake of what it was told to do. I should add that like Marx himself in the manifesto gave an example of this when he talks about basically like he's drawing on the metaphor of the sorcerer's apprentice, because basically you're teaching the broom, so to speak, to just like sort of give you infinite water. And Marx transposed that onto the relationship between, the bourgeoisie and the proletariat, that the proletariat will naturally kind of rise up and destroy their masters because they were told to do the wrong thing. But that's maybe a different topic. Moving ahead here. So basically this is just to say like accidents will happen in any domain, self-driving cars or otherwise, when there's some mismatch between the features that actually matter and those assumed by the agent or model as the designer specified them. I'll move ahead here since I'm limited on time, but basically optimization, a little bit more of an abstract problem than featurization, where the problem here is like, how is it you're managing the feedback between the system and the environment over time? So in the case of like, and actually my subsequent research speaks to this, self-driving cars or Uber or Lyft, ride-sharing fleets, basically can perform optimally but destroy roads at the same time because of road wear, or because they gentrify cities, or because they induce changes in the preference distribution of what their consumer model is of people. You can't take the world for granted when you make these systems work well. And another form that can take, and online like radicalization with social media is another, politically speaking, but that the world is material, the world is physical, and it will wear down the better you make these systems, because you're doubling down on features that are convenient for optimization, but otherwise those things need to be sustained in their own right, regardless of whatever the system's been told to do. So this is a different kind of damage that happens when when these sources of feedback are ignored or mismatched over time, sequentially, generating unstable conditions for performance. And then finally, just to give a brief example here, this is actually most illustrated best through APIs, but we just sort of call it the problem of integration, which is basically this problem where, again, with reference to self-driving cars, for example, you can make these systems very safe. You can make them drive accurately. You can help them understand stop signs. You can help them negotiate four-way stops perfectly, but you're still privatizing roads if you're Waymo or you're Cruise or you're some other company that's working with these modules. And so this problem of like, well, where exactly is the publicness of the domain? Roads are public. They're basically meant to be used however the public chooses to use them. So to optimize them, even in a sustainable way, could still contort them because you're basically putting yourself in the position of exercising discretion over what can or cannot be done with roads. So obviously roads are multimodal. There's this unanswered question of how pedestrians, cyclists, other human drivers, other modes of transport are meant to be sharing the roads with these systems, given that the systems we're building, AVs, automated vehicles, might be more optimal than other forms of transit. And that's a way in which the politics can be contorted. So in the case, again, of self-driving cars, one of the most common cases for my PhD thesis, there's this question of like how it is you're integrating a system in relationship with infrastructure that you're not meant to control. You're not meant to be in a position to have that kind of discretion towards. And again, there's an indeterminacy here about, well, what is the public interest once you're building a system that can squeeze so much more utility out of infrastructure that was never meant to be used that way. So just in closing, I'll say what the result of this framework was that me and my collaborators were building was the idea that designers, AI designers, are really only in a position to roughly fix the parameters of system performance when they bear on these different forms of indeterminacy. Precisifying can only get you so far in ways that are beyond your control. And really, I'll just say, as my final word, that like this is really all rooted in this problem that most AI systems today, we still have a relationship with them that historically is analogous to like what alchemy was in the 15th, 16th, 17th centuries, basically where you're in a closet, you're doing your own like fudging with like whatever this experiment is, but there's no ability for the public or any kind of external actor to weigh in and provide feedback on whether or not the alchemist is making accurate decisions about the chemicals you're manipulating. In other words, like AI is not scientific predominantly. And then I think actually to design AI in the interest of humanity will mean making it into a more scientific endeavor where these indeterminacies can be investigated by a more diverse group of stakeholders. So I'll end there. Thank you very much.